Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Designing AI Architectures. Building the blueprint for smart systems, planning how different AI components fit together to create a powerful application. Imagine you want to build a magnificent house. You wouldn't just start hammering nails, right? You'd need a blueprint, a detailed plan showing where the kitchen goes, how many bedrooms, where the pipes run, and how it all connects. In the world of AI, an AI architecture is exactly that, a detailed blueprint for your smart system. It's how we plan which AI parts, like a brain, eyes, or ears, fit together, how they talk to each other, and how they work as one powerful application to solve a specific problem. It's about designing the asterisk structure before you start coding the asterisk function. Why bother with a blueprint for AI? Just like building a house without a plan can lead to messy wires, pipes in odd places, or rooms that don't flow. Building an AI system without an architecture can lead to chaos. Your AI might be slow, hard to change, expensive to run, or simply not work well. A good AI architecture makes your system efficient. It uses resources wisely, scalable. It can handle more users or data as it grows. Maintainable. It's easy to fix or update. Reliable. It works consistently. From a developer's perspective, this planning phase saves countless headaches and lines of code down the road. Every AI system, no matter how complex, is built from a few fundamental pieces. Think of them like the bricks, wood, and concrete for your house. For an AI application, these often include 1. Data source, where your AI gets its information, like a database or user input. 2. Data pipeline, how data moves and gets prepared. 3. AI model, the brain that learns patterns and makes decisions. 4. APIs, application programming interfaces, how your AI talks to other software. 5. User interface, UI, how people interact with your AI, a website, an app, a chatbot. 6. Infrastructure, the computers and servers where your AI lives. As a developer, you'll be connecting these blocks, ensuring they communicate smoothly. An AI is only as smart as the data it learns from. Imagine trying to cook a gourmet meal with rotten ingredients. Disaster. This slide covers 2 crucial steps. 1. Data ingestion, getting the raw data into your system. This could be anything from customer reviews, sensor readings, images, or financial records. As a developer, you might write code to pull this data from databases, files, or external services. 2. Data pre-processing, cleaning, transforming, and organizing that raw data so your AI can understand and learn from it. This involves tasks like removing errors, filling missing values, or converting text into numbers. Think of it as washing, chopping, and preparing your ingredients before cooking. This ensures your AI model gets the best possible food to learn efficiently and accurately. This is where the intelligence lives. The AI model is the algorithm that learns from your prepared data to make predictions or decisions. Imagine you're teaching a child to recognize cats. You show them many cat pictures, and they learn what a cat looks like. An AI model does something similar. Choosing the right model. There are many types of AI models, e.g., for recognizing images, understanding text, predicting stock prices. Your architecture needs to decide which type of model best suits your problem. Training. You've trained the model by feeding it tons of data, allowing it to learn patterns. Evaluation. You test how well it performs. As a developer, you won't always build these models from scratch. Often, you'll use existing tools and libraries. like pre-built brains, and adapt them to your specific data and problem. Once you have your smart eye model, it needs to be accessible and useful within a larger application. 1. Integration. How does your AI model connect with other parts of your software? This usually happens through APIs. An API is like a menu in a restaurant. It lists what services your AI can provide. E.g., predict if this email is spam, recommend products for this user, and how other programs can request those services. 2. Deployment. This is about making your AI system live and available to users. It means putting your code and model onto servers or cloud platforms where it can run 24/7. As a developer, you'll use tools to package your AI application and set it up so it can receive requests and send back responses quickly and reliably. Think of it as moving your carefully planned and built house from the construction site to where people can actually live in it. Building an AI system isn't a one-and-done job. It's an ongoing process. 1. Monitoring. Just like you monitor your house's electricity or water, you need to monitor your AI system's performance. Is it running fast enough? Is it still accurate? Is it using too many resources? 2. Maintenance. AI models can drift over time as new data comes in or circumstances change. What was accurate a year ago might not be today. You might need to retrain your model with fresh data or update its code. 3. Improvement. Iteration. Based on monitoring and user feedback, you'll constantly find ways to make your AI smarter, faster, or more robust. This might involve collecting new data, trying a different model, or refining existing components. As a developer, you're constantly looking for ways to refine your blueprint and improve your AI's intelligence. Let's tie it all together with a practical example. Building a movie recommendation system like Netflix. Data ingestion. Collect user watch history, ratings, movie genres, and descriptions. Pre-processing. Clean data. Remove duplicates. Convert movie titles to unique IDs. Turn ratings into numerical values. iModel. Train a recommendation engine model, e.g., collaborative filtering, on the processed data to learn which movies users with similar tastes watched or rated highly. Integration. API. When a user logs in, the website calls an API endpoint like recommend _movies for _user_x . Deployment. The iModel and API are hosted on a cloud server. UI. The recommendations appear on the user's home screen. Monitoring. Track if users click on recommendations, improving the model over time. This entire structured plan, from data to display, is your AI architecture for the recommendation system. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.